Hello guys, today we are going to see a previous year get question of organic. So let's see. Organic chemistry. So question is that find the major product of the following reaction. Here the pyrrole is given. Sorry, furan is given. Treated with acidic anhydride. So we go through mechanism. CH3 C double bond O. So now this oxygen having lone pair attack here, make a double bond here. So this bond will shift here, it will make a double bond here, and this bond will shift here. So here negative charge will become. I am writing here, see, like this, it will look like this. Here double bond become, this bond will shift here, here double bond, this bond will shift here, so here negative charge. Okay, now this, here oxygen have a positive charge, so this negative charge will attack on this carbonyl, this bond will shift and come back here, and this bond will break. Okay, it attack to carbonyl, so this bond will go up, again it will come back, and this bond will break. So we get a C double bond O CH3 we get. Now here H is there, so this bond will shift here, this bond will shift, and this bond will shift here. So we get a here H plus will release, so we get here a C double bond O CH3. So this we get a product. This is your product. Okay, your double bond left. This is your product. So furan, it attack on the this carbon. So 1 2 3 4 5, it attack on the 5 carbon. Next, move to next question. So next question is C double bond O here and C2H5 twice. It is treated with first CH3I and second sodium bicarbonate and MeOH. So go through mechanism. C2H5, this is twice. The nitrogen having lone pair attacks here, and this I minus leave, so we get a C double bond O and CH3 C2H5, this twice. So here nitrogen having positive charge. Okay, now further it is treated with a base NaHCO3 sodium bicarbonate, so it will abstract this base, so it will abstract this H plus, which is acidic. this bond will shift here and this bond will shift here. So we get a O negative double bond, this N CH3 C2H5, this is twice. Now this MEO which provide a proton, so this is no oxygen having negative charge will abstract the proton from MEO, so we get a OH double bond, here NCH3 C2H5 twice. We get here this product. Now what happened? This bond will shift here, okay, and this bond will shift here, and this nitrogen having positive charge, this N and CH3. So this bond shift here, this bond shift here, and this bond will shift here. This, okay. So we get a product that here a double bond, this bond shift here, so here double bond, okay, plus this N CH3 and C2H5 twice, and this bond shift here, so here nitrogen having a lone pair, okay. This OH bond shift here to make a double bond, this double bond shift here to make this double bond here, and this bond shift here to nitrogen, so that nitrogen was having positive charge, it get neutralized, so we get this product. So this is our product. Now we take one more example, one more question. In that Beckmann rearrangement reaction is, so writing a question. This C double bond O, it is treated with the NH2OH, H plus, and H2SO, second is H2SO4, okay. So let's see a mechanism. This is a cyclohexane. It is treated with a NH2OH. So no lone pair of nitrogen will attack on this carbonyl group. This bond will shift. So we get a oxygen having negative charge, nitrogen H and OH. Nitrogen will have a positive charge. Now this H bond will shift here, and this H will abstract by this O negative. So we get a OH and sorry, here OH, because this H bond will shift here, it will neutralize the nitrogen, and this oxygen having negative charge will abstract this H, so we get OH and H, this OH, okay. Now further, here H plus ion is abstract by this oxygen, So we get a positive charge of oxygen and this NH and OH. Now sorry, we came till here, this OH and this is trans. Okay, sorry, I'm writing the structure here again. Here OH and H and here OH. So now what happened? This lone pair of oxygen will shift here. This bond will shift towards the nitrogen and this OH bond leave. So we get a 1 2 3 4 5 6 1 2 3 4 5 6 7 7-member ring. Here nitrogen, here double bond, 1 2 3 4 5 6 7. Yeah, we get this structure, which is a cyclohexyl oxime. Or I can show this one more mechanism. So this is a Beckmann rearrangement. So Beckmann rearrangement, I'm drawing a mechanism. This is cyclohexanone treated with H plus in acidic condition. The lone pair of oxygen will abstract this H plus. So we get a OH. Oxygen will become positive charge. Now what happened? This bond will shift towards oxygen. So here I am making a resonance structure. This is OH, and so this carbon become positive charge. Okay, now it is treated with the HN3. Okay, you can write this structure like this. So lone pair of nitrogen will attack on this carbonyl, this carbon which is the electron deficient. So we get a this OH here and triple bond and this H. Okay, we got this structure. After that it is treated with the H plus. So this oxygen abstract this H plus and become a here water. OH, H, oxygen positive charge, here N, triple bond, positive charge, and this H. Now this NH bond will shift here and this water will release. This NH bond will shift here, this water will release. So we get a this is double bond and here a nitrogen ion positive charge. Now further step, this bond will shift here and this N2 will release. So this bond shift here and this N2 release. So release of N2. So we get a here a 7-member ring. 1 2 3 4 5 6, here 7. So right here, and double bond like this. 1 2 3 4 5 6 7. So we got this. Now further it is treated with a water H2O. So this oxygen lone pair attack this here, this carbon, and this bond will shift. So we get a here is a nitrogen, here a negative charge, this bond will shift here. So here is a water. Now this oxygen has positive charge, this NH bond will shift, this OH bond will shift here. This negative charge nitrogen will abstract this H plus. This H oxygen, this hydrogen oxygen bond shift here towards the oxygen, so it neutralizes the oxygen, and this nitrogen having negative charge will abstract this H. So we get a NH, here a O, this OH. Now this bond will sorry, something is missing. Let me see. When this bond will shift here, so this carbon will having positive charge. So I forgot write to positive charge. So now with this oxygen lone pair will attack here, and this bond here, so there will be double bond. Sorry, here will not a negative charge, so double bond. So it oxygen lone pair attack here, so here, okay. So this carbon get neutralized, and this oxygen having positive charge, so this bond will shift here to neutralize the OH. So here will be a double bond, okay. So there will be no H either. Sorry for correction. Please correct. See, till here it was right. When I shift this bond to nitrogen, so this carbon will have a positive charge. So I forgot to write here positive. So I have written a positive charge. Now this treated with the water. So oxygen lone pair will attack on this carbon. So it neutralizes this. So we got this structure, and oxygen donated its electron to this carbon. So oxygen will have a positive charge. So now this OH bond will shift to neutralize this oxygen. So we got this structure. Now this OH bond will shift here, and this double bond will shift towards the nitrogen. So nitrogen will have a negative charge like this. Here a nitrogen, here a double bond. So when when the bond will shift here, it will make a double bond, and this bond will shift towards the nitrogen. So nitrogen will have a negative charge. You can see this here H plus is released, okay. This bond shifted making double bond, and this here nitrogen bond shift towards the nitrogen, this double bond shift towards the nitrogen, so it will get here negative charge. This negative charge will abstract the H plus, and which is released here. So if it will abstract the H plus, so we get here we get this product. Once again I will repeat this, that the cyclohexanone in presence of acidic condition, oxygen lone pair attack on the H plus. So we get here a OH bond. So oxygen having positive charge because it has donated its electron to the H plus. Now what happens? This bond will shift towards the oxygen to neutralize the oxygen. So this carbon will become a plus. So this carbon is electron deficient. It is treated with HNH3. So lone pair of nitrogen will attack on this carbon. Now we get this structure, and after that it is treated with the H plus ion, which is abstract by this oxygen lone pair. So here we get so in this we get this structure, and in this you can see that the oxygen having positive charge. So here what happens? This NH bond shift here to make a double bond, and this water will release. This bond will break. So water release. Now what happens? We get this structure. Now here this bond will attack on this nitrogen. So here the carbon will have a positive charge. When we shift this bond towards the nitrogen, this bond break because here N2 release and this carbon become a positive charge, so I have drawn here positive. Now in further it is treated with the water. This oxygen lone pair attack on this carbon, so it neutralizes the structure, and when the oxygen donates its electron to this carbon, so oxygen become a positive charge, and after that OH bond will shift towards the oxygen, so neutralize the this group. Now further this OH bond will shift here to make a double bond, and this double bond will shift towards the nitrogen, so that nitrogen will have a negative charge, and after that this nitrogen having negative charge will abstract H plus, so we got a this product, that is a cyclohexyl oxime. So it is a basically mechanism of Beckmann rearrangement. Okay. I will make a separate video of Beckmann rearrangement in few days. So thank you. I am